Beautiful day in the neighborhood. Thanks for coming. I appreciate you, some of you coming back today, some of you coming for the first time. We're going to have a lot of fun today. It's going to be, we're going to cut, like yesterday, we're going to cover a lot of material, a lot of ground. Debbie's head's about to explode, she said, or she's got a little bit of room left before it explodes. So,
real quick, Richard, how many more of the packets do we need?
Good question. Okay, so everybody should have a handout. Who is missing a hand? Who needs a handout? 4, 5? 5.
5? Okay.
Okay.
So I'll be back.
Okay, thank you, Patrick. All right. So yesterday we talked about DMX and RDM and a couple of other things. Today, we're going to switch gears a little bit and talk more about networking. Do you see this picture right here? Does anybody recognize where that's from? Sean knows. Tell him, Sean, where's it from? That's Eurovision Song Contest. And if you're unfamiliar with Eurovision, Eurovision is basically a European battle of the bands. It's been going on for 62, 63 years. And basically what happens is that every European country has its own battle of the bands, and the winner of that competition gets to go to the European Battle of the Bands, or Eurovision Song Contest. And it's a massive event. People come from all over Europe, and they paint their faces, and they drape themselves in the flag, and they just go nuts. They go wild. It's quite a spectacle. And that's just the audience that does that, you know. And so they have, when they broadcast, they have a television show, I think it's 4 nights in a row, and everything stops when the show is on. Everybody goes home and turns on the television and tunes in. So they have massive ratings, big ratings. Yeah.
What put it in perspective for me when I found out about it is it's bigger than the Super Bowl every night.
Exactly. Yeah. It's like they are it's like having 4 Super Bowls in a row, 4 nights in a row.
Olympics.
Yeah, it's bigger than the Olympics. So massive television ratings. So what that means is they have a big budget, massive budget. So, and you can see if you saw some of the pictures, you would see that they put that budget into the technology, into the show, because it's an incredible show. It's first of all, it's a big stage, but second of all, it is the latest and greatest technology. You know, everything is automated. They have automated lights. They have automated set pieces. They have robotic cameras. Everything is pre-programmed. They spend months and months and months ahead of time recording the songs and then programming the songs. And by the time they get to air, then everything is pre-programmed already. And they are basically running everything on SMPTE time code, and they press the go button, and it takes off, and it runs. This is probably the biggest front of house I've ever seen. And look at all the computers there. And really, that's a fraction of the computers they use for the entire show, because by the time they get to this point, everything's already pre-programmed. So most of these people here are just babysitting. They're sitting back with their arms folded, watching the SMPTE time code go by, making sure nothing goes wrong. It kind of reminds me of the factory of the future. Have you heard of the factory of the future? In the future, a factory will be a man and a dog. The dog is there to make sure the man doesn't touch any of the controls, and the man is there to feed the dog. You know, that's what they're doing. They're not touching the controls, you know. So, but to me, this is kind of a peek into the future of our industry. It's very cutting edge, and it kind of gives you some insight as to where we're going in the industry, because computers are getting cheaper and more accessible and more powerful and more capable, and also we're networking things together more. You know, all these computers are linked in one way or another, whether it's through SMPTE timecode or some other way on a network, you know. So we're going to spend some time today talking about how you set up a network, how you test it, how you troubleshoot it, because I feel like if you really want a future in this industry, then you're going to need to know something about computers and computer networking. You know, a few weeks ago, somebody posted on Facebook, they said, you know, I didn't get in the lighting industry to be an IT guy, but yet here we are, you know. And in a way, that's true. I'm not crazy about being an IT person, but I can't tell you how many times I've been in a situation to where you had to figure things out, how to make things network together and how to make them play well. And you know, a lot of it is configuration and setup, and then, you know, once you get to that point, it's like, how do you test it? How do you know it's working? How do you know everything's configured properly? And sometimes you have errors that cause things not to work, but you have no clue as to why. So for example, and you know, we'll get more into this later on, but if a few months ago, last year, we had a grandma console and we had a network switch. And when you're setting up a network, so this is a switch. When you're setting up a network, you use a switch to build a network. And so we connected the grandma console, and then we had a computer for a visualizer. Now, when you're first setting up the network, you have to make sure every device in the network is configured properly with the correct IP address and subnet mask. A switch runs a piece of software called Dynamic Host Configuration Protocol, or DHCP, that will automatically assign an IP address to whatever's plugged into it. And so does the console. But you're only supposed to have one DHCP server on a network. And we didn't know that the console was the DHCP server and the switch was the DHCP server. So what happens is that the switch would assign the computer an IP address, and then so would the console. So the switch had no idea what the real IP address of the computer was, so therefore it didn't work. But yet, it doesn't tell you, there's no error message, there's no warning sign, it just doesn't work. And there are situations like that. There are other situations where it just won't work because it's not configured correctly, and there's no clues as to why that's the case. You just kind of have to figure it out. So we're going to talk about what we can use to figure it out, you know. So, but anyway, let me see, where are we here? So the amount of data we're using has really ballooned. The early moving lights were very simple, didn't take a lot of control channels. And over time, they've gotten more complex, more complicated, so they use more control channels. And then we started pixel mapping, and that's when our bandwidth requirements really ballooned. And so today, if you have a medium to large show, or if you could even have a small show, but if you do something like pixel mapping, then now you've got a huge number of channels that you're trying to control. And so the old way of doing it with DMX, with the DMX cable, may not be the ideal solution because DMX is limited to 512 control channels per cable, or one universe, which is 512 channels. So it makes a lot more sense to start thinking about how we can do it with a faster protocol, and that faster protocol is usually Ethernet. So if we build an Ethernet network, that allows us to transport multiple universes of DMX, a lot more universes of DMX, over a single Ethernet cable. So we're going to talk about how that works. Now, there are a couple of landmarks in the industry in the fairly recent past. In 2008, which by technology standards is now ancient, 10 years later, the Beijing Olympics opening ceremonies, they went into what they call the Bird's Nest Stadium. So they went into the Bird's Nest Stadium and they set up a lighting system with 2,342 moving lights. And as far as I know, that's the biggest assembly of moving lights that I've ever seen, and it may be still to this day the biggest package ever assembled. It's a huge number of fixtures. They used 110 media servers. And now a media server, in case you're not familiar with them, is basically a computer that has video files that outputs video files to a video display, whether it's a projector or a video wall or a light that does pixel mapping, whatever. And so a guy named Scott Chmielewski came to Austin, and he figured out how to network 110 media servers together, because they were using Catalyst media servers, and at the time High-End was a Catalyst distributor. So, and it took him a while to do it, but he was able to do it. But that's an impressive feat in our industry 10 years ago, to build a network of 110 computers. As far as I know, nobody had ever done that before, but they pulled it off. And those media servers were driving 131 video projectors, which projected onto the surface of the bird's nest, which was about 2,000 linear feet and 45 feet high. They had 3 lighting consoles. They had a team of programmers, because no one programmer could have programmed this many moving lights in the amount of time they had, and they had months to do it, but it took a team of programmers. One person programmed the hard edge lights, one programmed the soft edge, and one programmed the sky trackers along the floor here. And they used 37 universes of DMX, which at the time was a huge number of DMX universes. Remember, a universe of DMX is 512 channels. So to use 37 of them, that's like, wow, that's huge. You know, now, to put it in perspective, a couple of months ago, a few weeks ago, I read an article about a corporate event where they used 1,024 universes of DMX. So, you know, there was a time when I thought, 37, nobody will ever top that. Well, we're getting there. We're getting there. So, in that particular show where they used that many universes, they did a lot of pixel mapping, which makes sense. You know, if you have massive video wall with lots of pixel mapping, you're going to need a lot of control channels. So, now, this was the 2008 Olympic opening ceremonies. In 2012, the game had kind of changed now. We had gone from using media servers with projectors more into pixel mapping, which means that now we have even more control channels. So if you look at how did they map that graphic into the stadium, well, they used these pixel tablets. Tate Towers built these custom pixel tablets. It's a 3x3 RGB LED array, one for every seat in the stadium, and there was 70,500 seats in that stadium. So essentially what they did, think about this now. What they did is they went in here and they ringed the stadium with fiber optic cable. That's called the backbone to build the network. And then they connected a bunch of switches to convert it back to copper. And they ran one node of the network, one connection point for the computer network into every seat in the stadium. So essentially they had 70,500 devices connected on one network. So again, it's a massive feat. But it's no longer brute force with 2,000 lighting fixtures. Now it's brute force with 70,000 pixels, RGB pixels. So you can see how our bandwidth requirements are increasing, which makes sense why we're moving more towards Ethernet-based control, because Ethernet's a lot faster than DMX, which means you can transport a lot, you have more bandwidth, you can send more data over an Ethernet network. So, all right, so we're going to start talking about how you. Well, hang on a second. Let me think about it. So I set up a Wi-Fi network, and at some point, you know, if you have a laptop, then we're gonna do some exercises on the network. Okay. If you don't have a laptop and you have a tablet, you can do these exercises with the tablet, but you're going to need You're going to need an application called Well, it depends on whether you're on iOS or Android. If you're on iOS, you can download, and it's free app, it's called iNet Tools. If you're on Android, it's called Fing, F-I-N-G, and actually Fing works on iOS or on Android. So we're probably going to do that in the next 30 minutes or so. So I'm just kind of giving you a heads up. So you'll have time to connect to the internet, download the app. It's a free app. And then by the time we're ready to do these exercises, you should be ready to go. Now, if you don't have a computer and you don't have a tablet, you can use a smartphone for the same exercises, the same software. iNet Tools for iOS, Thing for Android or iOS. And if you don't have a computer, a laptop, if you don't have a tablet, and you don't have a smartphone, I'm sorry, I can't help you.
You're saying Thing, F-I-N-G?
Thing, F-I-N-G. George, sorry. Kyle.
I'm connected to that network. I'm connected to it, but I don't have internet access.
That's right.
Correct?
Yeah. So when we get on, we're building a private network. We're intentionally not connecting to the internet. So there's a couple of reasons for that. One is we don't need access to the internet. And number two, we don't want to invite hackers. Anytime you connect to the internet, then you have a whole world of people who wear black hats and live to do nothing more than to mess with you. And this is, right now, network security is a small issue in our industry. Soon, it's going to be a big issue in our industry. There's all kinds of Internet of Things. There was a case where a hospital, I think it was a hospital, had a internet thermometer for their aquarium, right? Internet thermometer for their aquarium. So you can get on your smartphone and you can check out the aquarium and go, oh, the temperature is set correctly for the aquarium, the fish are okay. You can do that from anywhere in the world, right? Well, a hacker figured out how to use that internet thermometer as a door to get into the hospital's network, and they stole all the data from it. So every time you connect something to your network, there's an opportunity for somebody to hack into your network and take control of it. And if you're running a show and somebody hacks into your show and takes control, that's not a good, you could lose your job, right? So in the future, we're going to have to start thinking about how we can lock down and secure our networks. And one of the ways is we're building a private network. We're not connecting it to the internet, okay? So the next person that logs onto the network and says, hey, I can't get on the internet, I'm going to make you run laps around the building, okay? No, I'm just kidding. But we don't have internet access. We're building a private network, if that makes sense, okay? All right, so we'll probably do that in the next few minutes. In the meanwhile, I just kind of want to talk about the evolution of the industry and how we got to the point where we are. The first moving lights I ever saw were analog fixtures. They were Clay-Packy Golden scans. Now, analog control, if you have a moving light with analog control, then that means that every motor on the fixture has to have a pair of wires to control it. Now, in this case, it was one wire and a drain. So every motor had one wire and a drain connected to it. So there were actually 5 motors, pan, tilt, color, gobo, and shutter. And so it's controlled by an 8-conductor cable with the shield. And so it had an 8-pin DIN connector, and that meant that we had to run one cable to every fixture. And if you've ever set up a system like that, it's not fun because you spend a lot of time running cable and routing cable and hiding cable. And then the controller itself has to have one port for every light on the back. So on the back of this controller, which is like this big, there were 24 connectors, one for each light. So that controller could only control 24 fixtures. So obviously that was not a very good solution. So in 1986 is when we came out with DMX. And the advantage of DMX is that now you can daisy chain the cable. So you have a home run from the console to the first fixture, and then you come out of the first fixture into the input to the second, output of the second to the input of the third, and so on, and you daisy chain your fixtures. But of course, you can only control 512 channels with one home run. So as our devices became more sophisticated and used more channels, now some of them use half a universe. That means you can only put 2 fixtures on one link. And also, our lighting systems got bigger and bigger. And it's kind of like an arms race. Like one band would have 100 fixtures, so the next one would want to have 101, and then 200, and then 300, and it it just keeps going. So eventually what happened was that we outgrew that 512 channel count, the universe. I think, and the first time I ever heard that term, I don't remember exactly when it was, but I want to say it was early 1990s. I was talking to a friend of mine who was working a show in Las Vegas, and it was a Britney Spears DVD shoot. And he told me they had 360 automated lights, and I was shocked, because back then, if you had a system of 48 lights, that was a big system. Nobody, I'd never heard of one show that had 360 lights. That's insane. And it was right around the same time somebody told me that they were using 2 universes of DMX, and I'm like, and I'd never heard that term before, but I immediately got it. I immediately knew what he was talking about, but I was flabbergasted. I'm like, you mean you need more than 512 channels of DMX? He's like, yeah, we need 2 universes. And mind blown. It's crazy. So we got into the situation where we started needing more and more home runs. So it kind of defeats the purpose of DMX. So what happened was, in 1995, this was right around the time that Ethernet networking started becoming more popular. And so somebody from Strand went to a standards committee meeting, and they suggested that we develop a new lighting control standard that takes advantage of Ethernet networking. So they started putting together this protocol, the standard, and they called it Architecture for Control Networks. It took them 11 years to develop it, because it's what's called a consensus standard. A consensus standard requires a consensus from the industry. What they'll do is they'll form a committee, and they'll write a draft proposal, and they'll put it out for public review, which means that anybody in the industry can comment on it, and they collect all the comments. There's a commenting period, and then they have to address each and every comment. So if they get 100 comments back, they have to answer each comment. They may not accept the comments. They may say, well, we think it should be done the other way. So they could reject the comments, but they have to address them all. Or they could embrace the comments and change the draft standard. So they address all the comments, and then they rewrite the standard, the draft, and then they have to put it out for another public review and collect all the comments, go through the commenting period again. And they do that over and over and over again until when they send it out for public review, nobody comments on it. When they get no comments back, then it can become a standard. And that took 11 years. And by that, the industry is not going to sit on their hands and wait 11 years for a industry standard protocol. So what ended up happening is that a lot of manufacturers developed their own proprietary protocols. And that's why we have, for example, ETC-Net 2 and ETC-Net 3, and Strand ShowNet and CompuLight Network and Pathport Protocol, and all these other protocols that are proprietary, and they all do exactly the same thing, which is they transport DMX over an Ethernet network. But they all do it in different ways so that they're not interoperable. You can't use a Strand console and talk to an ETC dimmer rack without having a gateway or protocol converter in between. So in 1998, Wayne Howell and the folks at Artistic License developed a protocol called ArtNet. And ArtNet, once again, is another way of transporting multiple universes of DMX over an Ethernet network. But what they did differently is that rather than make it proprietary, they released it as an open protocol. And a lot of manufacturers embraced it, console manufacturers, and they put it in their consoles. And so from 1998 onward, most lighting consoles have the option to either output DMX or ArtNet, which is an Ethernet-based protocol, or both. And then later on in 2000, when ACN came out in 2006, it was not embraced by the industry. And so the committee went back and wrote another protocol called Streaming ACN, which again is very similar to ArtNet in that its purpose is to transport DMX over an Ethernet network, except again it does it in different ways. So there's differences between ArtNet and streaming ACN. And this is an industry standard protocol. It's a consensus protocol, and it is embraced by the industry. So today, most consoles you can use to either output DMX, or you can output ArtNet, or you can output streaming ACN. Okay, but these are both Ethernet-based protocols. So the first step is to build an Ethernet network. And I kind of think of it as building roads and freeways and overpasses and bridges. If you want to transport people, if we wanted to get in a bus and go to Venice Beach from here, the first thing we're going to need are good roads, right? And the second thing we're going to need is a bus to carry us over there, right? So I liken the roads as the Ethernet network. The very first thing, if I want that console to talk to this lighting system, I have to pave the roads. And the way I pave the roads is I'm going to take a switch, I'm going to build a network. And when I connect the wires, those are the roads. And if I have a wireless link in here somewhere, those are the bridges. So I need the infrastructure in order for the system to work. And then the cars are like the Ethernet-based protocols. So we have the ArtNet cars or buses, and we have the streaming ACN cars or buses. And then what do we put in the cars? Well, the DMX data. So the DMX data is like the people that are in the cars being transported from here over to Venice Beach or wherever they're going, or in this case, from the console up to the lighting system. So it took me a long time to figure this out. Of course, you guys are smarter than I am, but it took me the longest time to figure out that if the Ethernet network is not working, your lighting system is not going to work, regardless of whether you've got the console configured properly for ArtNet and you have the right IP addresses and all that kind of stuff. Yeah, John. Had to think about it.
Just out of curiosity, are we going to get to like a managed versus an unmanaged switch?
Yes, we will talk about the difference between a managed and an unmanaged switch. And the short answer to that is a managed switch, there's two kinds of switches. There are managed and unmanaged switches. A managed switch has a lot of features and configurability, and it has things like firewall, built-in firewall, and antivirus protection, and denial of service attack protection. Whereas an unmanaged switch is a very simple plug-and-play device. I carry around with me, let's see if I can find it in my pile of stuff here. It's too dark. For different exercises. But an unmanaged switch like this is a very simple plug-and-play device. Now, there is some configurability with this. So, for example, I can use this to mirror ports, and we'll talk about the significance of that later on. But for the most part, this is plug-and-play. So, in some instances, you want an unmanaged switch because sometimes a managed switch is very difficult to configure because of all of the features and all of the protections. DMX is a constant stream of data from the same fixture, from the same device out into the system, right? It looks to a managed switch very much like what's called a denial of service attack. That's how you bring down a network. If several years ago, when people tried to bring down Twitter, they wanted to crash the Twitter site. So what you do, if you're a bad guy and you want to bring down a site, is that you will collect bots or you buy bots. And that is when, if somebody sends you an email and says, here, open this attachment for me because here's your invoice. Don't ever open attachments in your email. Never open attachments unless you 100% absolutely know that you're supposed to be getting that. And they will often make it they can obscure where it's actually coming from. They can fake the name that it's coming from, so it'll look like it's coming from your buddy, right? Or from your boss. And your boss will say, hey, open this attachment. And you open it up, and it downloads a Trojan horse, which is a piece of software script that runs on your computer unbeknownst to you, and it reports back to the guy wearing the black hat, and it says, okay, we've got another one. And if you do that hundreds of thousands of times, when the bad guy's ready to launch an attack, he presses a button and directs all of those computers to send data over to Twitter, the Twitter server. And it gets so much traffic that it crashes the network. That's called a denial of service attack. And DMX looks very much like a denial of service attack because it's a stream of data coming from the same IP address. And so a lot of switches, a lot of managed switches interpret that as a DDoS attack, which is a distributed denial of service attack or just a denial of service attack, and it will not let DMX data through the network. So sometimes you're much better off using a simple unmanaged switch that's plug and play for that reason, okay? So, yes, sir.
Question on the protocols. If ArtNet was already open source and it was already embraced by the industry, why did ACN?
Okay, so Ray brings up a good question. Ray said if ArtNet is open source and was already embraced by the industry, why did we develop streaming ACN? And the answer is that ArtNet is not perfect. And there are some issues with ArtNet. That's why there's actually 4 versions of ArtNet today. And it has to do with what's called casting. The original version of ArtNet was broadcast to every device on the network. Now, keep in mind, in 1986, our systems were smaller, our instruments were more simple. So traffic congestion on the network was not a big issue. Just like in the 1950s, the freeways in LA, there wasn't that much traffic, right? There were no traffic jams in the 1950s. And then fast forward, our systems developed, the lights became more sophisticated, so they started using more bandwidth. And so now you need a new way to prevent the traffic from slowing down. And so in the second version of ArtNet, they went to unicasting, which is so broadcast is like a television station or a radio station. They'll just send the signal out, and anybody that's got a receiver can turn it on and tune in. So they're broadcasting to everybody. Unicast is more like a cell phone. If I dial your number on my cell phone and talk to you, I'm unicasting to your phone. Nobody else in the room, in the world, is receiving that data except for you. That's unicast, one-to-one, right? So unicast uses less bandwidth than broadcast, but more bandwidth than multicast. So streaming ACN is a multicast protocol, whereas ArtNet is a unicast protocol. Now, having said that, most consoles, when you go in to configure them to output ArtNet, will default to broadcast. So if you turn off broadcast, then it's unicasting. But that requires you to enter in the IP address for every single device that you want to receive the data. Now, in the old days, that meant you had 1 or 2 gateways that would receive the data, ArtNet data, and convert it to DMX and send it to the fixtures. But more and more, we have fixtures that take ArtNet directly, which means that if you want to unicast and you have a big system where you're distributing data purely through ArtNet, that means you have to put in the IP address for every single device, every single light into the console. And it takes a long time. It takes a lot of work to do that. And so streaming ACN, on the other hand, uses a piece of software called IGMP, which means that when the fixtures are connected to the network, they automatically subscribe to a particular multicast. So streaming ACN is pretty much plug and play. And because ArtNet defaults to broadcast, sometimes if you have big systems, it can crash. And so for that reason, I know a lot of people who are switching over to streaming ACN. But the latest version, we live in a time when things are in flux. Things are changing all the time. So what's happened in the recent past, last December, they came out with ArtNet version 4. Version 4 actually uses the IGMP from streaming ACN. So that means now it can be plug and play. And so then there's another important difference between ArtNet and streaming ACN, and that is that ArtNet, you can do RDM with ArtNet, but streaming ACN does not do RDM. So if you want to use RDM with ArtNet, with the Ethernet-based protocol, you have no choice but to use ArtNet. So there are trade-offs to each. So depending on your circumstances, you may choose one over the other. Does that answer your question, Ray? And then some?
So is there plans to bring RDM into streaming ACN?
There are plans. That's an excellent question. Ray said, are there plans to implement RDM with streaming ACN? The answer is yes. And the solution that they're working on right now is called RDMNet. So there's already been several draft proposals, draft standards for RDMNet that have gone out for public review. And there's currently, I think there's one out for comment right now. And it's been under development for a few years. And there's no way of knowing when it will be finished. You know, 2 or 3 years ago, I used to say, oh, any minute now we're going to have RDMNet. But I stopped saying that because it's just kind of, you know, it's taken a while. But it is coming. So that is coming. Okay? Yes. Wait, you're Raphael.
Yeah, can you go into a little bit more about the IGMP? We had a customer that had an issue with some flickering, but I remember we had to make sure that their switches were IGMP snooping compatible.
Yeah. Okay, so Raphael said that they had a customer who had issues with flicker, and the solution was they had to get a switch that was running IGMP. So I don't know a lot about IGMP. I know it's a piece of software that you have to have if you want to use multicast. So multicast is a way of sending data to a group of devices. So it's kind of like if you have the old television with rabbit ears and you're just picking up the signal in the air, you're picking up a broadcast. On the other hand, if you want to subscribe to cable, then you call up your cable provider and you sign up for cable service. So you're a subscriber. So that's basically what happens with these fixtures, is that these fixtures, when they connect to the network, if they're running IGMP, they will subscribe to that multicast. So if the console is set for streaming ACN relies very much on IGMP. So if the console is running ArtNet, it is also running, if it's running streaming ACN, it's also running IGMP. The fixtures, if the fixtures understand streaming ACN, they are also running IGMP. But if the switch in between is not able to understand or interpret IGMP, then you've got a broken link between the two. So if you want to use streaming ACN, that means your network has to be IGMP compatible. Now, I wasn't aware that there are switches that are compatible with IGMP and some that aren't, but maybe that's a feature you have to turn on or off, or maybe it's a particular switch you have to buy. Does that make sense? Yes, sir. Great. Any other questions or comments? Okay. Why don't we do this? We're going to take a 10-minute break, and then when we come back, we're going to jump on the network and do some networking exercises.